I first learned about Joe from Making North America video. I've shared with you guys before that there's some great folks in that video, and we've had a number of them as guest speakers. And then Joe gave a talk through the Tate Museum for their paleontology series, and we managed to show up right as the meeting was over, and he was in the show and, or I mean the question and answer part. So I sent an email to Joe and asked him to join us, and he was kind enough to say yes, and here he is. So I'm done talking. Joe, it's all yours.
Yeah, great. Thanks, Aaron. This is a real treat for me. I love talking about my dinosaur discoveries and the discoveries we're making out here in Denver. So thank you for inviting me. This is a lot of fun. So I've been at the Denver Museum now for 10 years. I overlapped with Kirk Johnson, who you saw recently. I think Bruce, he's talked glowingly of your crabs for years. So I overlapped with him when I first started here at the Denver Museum before he moved on to the Smithsonian for about a year and a half. And keep in touch with him still, do a lot of work with him still, including the Making North America video. And since he left, we've been making a lot of great discoveries of dinosaurs, both in the Denver metro area here and also around the West. And so that's what I'm going to share with you all today. So this is a reconstruction of what Denver used to look like. So this is a discovery that was made in the early 1990s, in 1992, in one of the suburbs of Denver. It was a T-Rex discovery, literally in the backyard of a house, a housing development. There's still bones that need cleaning, and given the preservation of the site, I suspect there's still a skull of a T-Rex in whoever ended up buying that house in their backyard. So someday I need to go and offer to put in a swimming pool or dig up their backyard and re-landscape or something. There's still a T-Rex out there. And this is a great illustration of the fossils that are right under our feet here in the Denver metro area. One of those finds that we made a couple years ago was a big Torosaurus discovery. This is from the suburb of Thornton, which is on the north side of Denver. And this is one of our big discoveries. It's turned out to be one of the most complete Torosaurus dinosaur discoveries ever. So it's most of the skull, about 99% of the skull, and about a quarter of the skeleton. Here's a reconstruction of what that Torosaurus would look like in ancient Metro Denver, along with some other dinosaurs that are, and turtles that are parts of our ecosystem here. And this highlights the other thing that we really like to do, and this is something we inherited from Kirk and some of our other scientists here, and that's the plants and reconstructing the entire ecosystem. So it's not just dinosaur digging, it's not just going out and looking for the next best big dinosaur. We're interested in the entire ecosystem and understanding how dinosaur ecosystems change through time. And so Denver sits on that last dinosaur ecosystem in North America, the T-Rex, Triceratops, Torosaurus ecosystem, the last million years. Just outside of town, on the north side of Colorado, we have another older discovery. This was a skull that was found in the 1980s, in 1982. It's been sitting up in northern Colorado in one of the public buildings for the last 38 years. And recently we brought it down to the museum. We've been re-preparing the skull. And it turns out it's from the next older unit here in the Denver Basin. It's called the Laramie Formation. And this pushes this particular dinosaur into some older rocks. So after some reinvestigations, we think that this is probably not a Triceratops. It was nicknamed Pops back when it was discovered. So it's called Pops the Triceratops, but it actually looks like an older lineage of horned dinosaur, probably similar to a dinosaur, a really rare dinosaur from Alberta called Eo Triceratops. And this might end up being the most complete skull of this really rare horned dinosaur. But for today, I want to talk to you about something that's a little bit older. So in order to get into the older rocks, we have to leave the Denver metro area, and we have to go back to a time when North America was split by the Western Interior Seaway, and the western landmass that was created by the split has been nicknamed Laramidia. That's based on the orogeny, the mountain building event, the Laramide. This actually predates a lot of the Laramide. This goes back into about 85, 88 million years when that seaway separated back to an older Rocky Mountain uplift called the Severe Orogeny. But what is really great about Laramidia is it preserves some of the best dinosaur ecosystems probably on Earth. And as you'll see through this talk, we're able to compare dinosaurs from north to south along a latitudinal gradient, something you can't do anywhere else. Most places on Earth, you can find a nice, really well-preserved dinosaur ecosystem, but it's a single point on the ancient globe. And at this point in Laramidia, we can actually compare north to south, something you can't do until later in the Cenozoic, something you can't do until about 15 million years ago. And so here in the Rocky Mountain West, we have amazing fossils from the end of the Jurassic with the Morrison Formation. We have amazing fossils from the end of the Cretaceous. So you see the stars popping up at the top of the screen here. Those are the ones we have in the Denver metro area. A lot of people are familiar with the middle of the Cretaceous dinosaurs, things like Utah raptor from eastern Utah, but dinosaurs that extend down into Texas and Oklahoma and all the way up into Montana from this era. And what we're talking about is Laramidia time. And this is between about 85 million years ago and about 72 million years ago. So this fairly long window in time, this fairly long snapshot. And as I said, this is a really unique opportunity to look at dinosaur ecosystems because those early mountain events were burying dinosaurs on that eastern flank, that eastern coast of Laramidia, and these big foreland basins sandwiched between the mountains and the fluctuating sea. And so dinosaurs from this Laramidia time period, so from this window in time, have been known for over 120 years. And some of the most famous dinosaurs that fill museums around the world include things like the horned dinosaur Styracosaurus that you see on the right, early tyrannosaur relatives like the foreground snorting tyrannosaur you see there. And this illustration highlights not only those really well-known formations, so the Old Man Formation, the Dinosaur Park Formation, which are in Canada, the Judith River and Two Medicine Formations in Montana, but it also shows what I call the Big Four. And in Laramidia, the Big Four are duck-billed dinosaurs, they're the horned dinosaurs, the armored dinosaurs, and then tyrannosaurs. And so throughout the rest of this talk, you'll see me referring back to these four different groups. And that by no means is the limit of diversity. So you see in this scene, there's other smaller dinosaurs. So we have ornithomimids, the ostrich mimic dinosaurs, the dome-headed pachycephalosaurs, a plethora of birds and dromaeosaurs, or raptor dinosaurs. But these are the big four that have really taught us a lot about the way ecosystems change through time along a gradient, a north-south gradient. And so if we look at that gradient, this is what the Western interior basins look like today. So these black blobs on the left are areas where the rocks are exposed from this time period. And the stars that I've dropped on top of that are great places to find dinosaurs in the north. So those are those four formations that I mentioned in the previous slide, the Old Man and Dinosaur from southern Alberta, the Two Medicine and Judith River from Montana. And for about the same period, we've known of other southern finds. So places in southern Utah and New Mexico and down into the Big Bend region of Texas. And that even extends down into central Mexico, into Coahuila state in Mexico. And there are other areas where dinosaurs are known in between. But I would say largely it's those 6 bright red stars for which we have most of our information, most of our data. And the work that we've been doing is focusing mostly on those southern 3. There are a couple of other sites that are producing really nice fossils. This one in Wyoming just recently has started to produce some nice horned dinosaurs that could be new, so new species. And this is what those rocks typically look like, classic badlands, places if you're a dinosaur hunter, you'd want to go. You want to spend most of your time camping out in these areas. So in the upper left is Utah, the upper right is southern Alberta, the lower right is eastern Utah and western Colorado, and the lower left is New Mexico. So just classic fluvial, so river dominated coastal plains with lots of muds, lots of big sandstone bodies that represent the channels of the river. And this is where dinosaurs wanted to live. This is a flourishing ecosystem where we get fossil plants, we get fossil invertebrates, so we have amazing gastropods and bivalves. And the thing I'm most interested in are the vertebrates, so dinosaurs and crocodiles and turtles and things like that. So if we look at these stars of where to find dinosaurs, and we actually represent that on time. So there's a time scale on the far left. Those are millions of years ago. And you compare each of those different formations along that time scale, you can see that they represent snapshots in time where you might find dinosaurs of a given age. So each star on the right on Laramidia represents a bar in the center. And each of those represents a certain amount of time in Laramidia. And what's really great is a lot of those bars overlap. So we can actually make meaningful comparisons from north to south where we have good overlap in formation. So you're going to see this slide a lot through this talk, because this is what I'll refer back to when we talk about differences from north to south. And so the big question that we're trying to address is, how were dinosaur ecosystems distributed across a major latitudinal gradient? So how did they change both through time, but also in space from north to south? And as I mentioned, we're doing a lot of our work currently in the south. So we're located in Denver. We're really close to a lot of these sites in New Mexico and southern Utah. We also have some early work that I've started up in northwestern Colorado. And then I'm working with a partner down in Texas, and I'll show you a couple of those fossils at the end of this talk. But really, we're going to focus on Utah and New Mexico for the bulk of this. And these are some of the most remote, rugged places left in the lower 48. So these are these last dinosaur badlands that are so remote, so difficult to get into, that they've largely been neglected. Unlike some of the sites up in the north, up in Montana and Alberta, which are out in the Great Plains and fairly easy to get to with trucks, these are really big, deep canyons. So this is a site you can see our crew hiking out to collect fossil plants. Our camp is way up at the top. We usually have to hike in about 4 to 5 miles each direction. And in this particular site, there was an elevation loss and gain of about 1,000 feet. So you climbed down and into the hole, collect a ton of fossils, and then you have to carry them all up this big mountain and back to the camp. So it's a lot of work. And that's one of the reasons it has been largely untouched for so long. And so there are other challenges, obviously. So this is, this is me putting Kirk Johnson's truck in a hole. He still never lets me forget that. The rock is really hard. So not only is it really hard to get in to find the fossils, but once you do find them, they're usually in concrete style rock. We recently uncovered a paper from the 1930s of early exploration of this region in Utah, where they found amazing fossils, but they were stuck in these big boulders of sandstone. They couldn't get them out. So we've been able to use newer technology. This is a demo saw, a cutoff saw with a diamond blade, to just score into the rock and knock these blocks out. So you can see in the background there, all of these big sandstone cubes of rock that we've hand chiseled out after coming through with the rock saw. And this site preserved most of an articulated duck-billed dinosaur with a mixed in portion of a raptor dinosaur that's probably a new species. So it's worth it in the long run. And because most of these areas are BLM, and because they're so remote, they've become wilderness areas or wilderness study areas. And that means they have an extra level of protection to preserve the wilderness aspect. And that means we can't use wheels. So everything has to be hand carried. So all the fossils are carried on backboards, which obviously serve a secondary purpose in case anyone gets hurt. We've only had to use the backboard for people a few times, luckily. So it's usually used for fossils. So that's us carrying one of the dinosaur chunks from that quarry that I just showed you. So that's a piece of the duck-billed dinosaur coming out of the site. And the big revolution was being able to use helicopters. And so this is a duck-billed dinosaur skull and neck completely encased in skin. And we would have never gotten this out except for the support of helicopters. So we were able to pull big fossils out. Most helicopter loads can handle up to about 1,500 pounds. This particular block was pushing that. I think it was about 1,650 pounds. But we were able to get this one out. And we're also able to put camps in using helicopters. So we'll drop a camp in way, way back in the backcountry so that we don't have to do that big 10-mile hike every day and climb up and down the mountain. And then we'll just fly everything out at the end of the season. So we've been able to make amazing progress using helicopters. And the reason we do that is because, as I mentioned, the fossils are just absolutely amazing. So this is an example of dinosaur skin. Almost all of our duck-billed dinosaurs are completely encased in skin impressions. So you can see the different tubercles there on the right with different sizes and shapes of the scales. We're finding dinosaur nesting sites. This is the first southern Laramidia nesting site. So a lot of you are probably familiar with some of the classic dinosaur nests up in the north in Montana that Jack Horner found back in the 70s. These are some of the first sites in the south, and they're quite different because they preserve successful nests. So it's a different type of depositional environment. Up in the north, it was much more arid. but there were pulses of floods, and those floods preserved dinosaur nests intact. These are successful nests. So these small dinosaurs hatched, then they lived in the nest for a period of time, and as they lived in the nest, they trampled all the eggs that they hatched from, and so all we get are little pieces, but we get a nice little pavement of just solid shell and other bits of bone, including bones of meat-eating dinosaurs that came in probably scavenging on dead hatchlings. We also find other aspects of the ecosystem, as I mentioned. So these are giant turtles. This is at a site that preserved a really nice horned dinosaur skull. And this is a really nice big turtle called Basilemes. There's another one in this block in the back. You can kind of see the edge of the shell poking out. And we know that these are all females. And the reason we know that is because inside each of these shells, which include articulated arms and legs that are pulled in, are completely full bellies of eggs. So these turtles were coming to the sandbar, it's a point bar deposit, probably to lay their eggs when they all got buried suddenly by a big flash flood event. And so these are all coming in at the same point, all ready to lay eggs, and some catastrophe took them all out at the same time. So kind of a sad story, but good for us as paleontologists. And this is a reconstruction. It's an early version of a reconstruction of one of these ecosystems. So this is that classic dinosaur ecosystem from Laramidia that highlights those major components, the four big groups. So horned dinosaurs, duckbills, tyrannosaurs, and the thing that's not shown in here are the armored dinosaurs. So those are the big four. So for the purpose of this talk, I want to focus, like I said, on Utah and New Mexico. And at the very end, I'll touch on some of the new discoveries we're making down in West Texas. But in Utah, we're working in two different rock formations, the Kaperowitz Formation and the Wahweap Formation, which you saw highlighted at least a little bit in the Making North America video, if you watched that. In 2014, I started a new project to complement the work in Utah in New Mexico, and that's in the Fruitland and Kirtland formations. And then down in Texas, we're working on what's called the Aguja Formation. So I want to start with the Kaperowitz. So we're going to spend most of our time on the Kaperowitz. This is really the crown jewel of Laramidia, at least southern Laramidia, and really forms the cornerstone of the Laramidia project here at the museum in Denver. And so the Kaperowitz Formation was deposited in southern Utah in what's now Grand Staircase Escalante National Monument. The rocks date between about 76.8 to about 74 million years ago. So it's about 3 million years of time. And it's over a mile thick. So there's incredible depositional rates. When you get those incredible depositional rates, you get things like skin and nests and turtles full of eggs. So we're really lucky to have this amazing stack of rock down in southern Utah. And the other great thing about the work down in southern Utah is these dinosaurs perfectly overlap with a dinosaur unit up in Alberta, the one I mentioned before, the Dinosaur Park Formation. In fact, the dinosaur bearing interval in both of these is so close that we thought the volcanic ashes that bracketed the dinosaur bones were the same volcanic events. We went back and fingerprinted the ashes. They're not the exact events, but they're within a few tens of thousands of years. So within the error of the dating technique, they're that close in time. So we're actually making a great comparison, an oranges to oranges comparison rather than apples to oranges. So we can say for sure that the dinosaurs in Alberta were living at the exact same time as the dinosaurs in Utah, plus or minus a few thousand years. And over the last decade or so, probably about 11 years now, we've named and recognized at least a dozen different dinosaurs. That includes new species of duckbills, new species and genera of meat-eating dinosaurs, you can see at the bottom, and a couple of other interesting new dinosaurs. So really amazing discoveries already coming out of the Kaperowitz. These are by far the highlights of the dinosaur discoveries. These are the horned dinosaurs. And right now we recognize three distinct different types of horned dinosaur from the same interval in the Kaperowitz. That's Utah Ceratops on the left, the bizarrely horned Cosmoceratops with kind of weird bangs in the front in the center there, and then Nasutoceratops, the big-nosed bull-horned one on the right. And so those three are some of the best preserved horned dinosaurs from anywhere in southern Laramidia. And what's interesting when we start to compare is we see that they're quite different from their northern counterparts. So for the horned dinosaurs, at least, we have a difference in numbers. So the Dinosaur Park Formation has 2 at any given interval. And in the Kaperowitz, we have 3 coexisting. And when we compare, they're different at the genus level. So they're completely different genera of horned dinosaurs. So we have in the north, Centrosaurus, and in the south, Nasutoceratops. We have Chasmosaurus and Utaceratops. So completely different dinosaurs. And as I said, these are living at exactly the same point in time. How do you get dinosaurs that are the size of rhinos or elephants segregated along a latitudinal gradient on a continent that's 1/5 the size of modern North America? So that's the big research question. When we look at duckbills, we get a similar story, although these are only different at the species level. So in the north, we have 3 different duckbill dinosaurs. In the south, it's flipped. We only have 2, but they're different species of the same genus. So the top one is a genus called Gripposaurus. And in the north, there's a species called Notabilis. Down in Caperowitz, it's called Monumentensis. Same for the tube-crested Parasaurolophus up in the north. We have a different species than what we have in the south in the Caperowitz, which is a still unnamed species of Parasaurolophus. And so that's led to a number of theories, namely a big one called dinosaur endemism or dinosaur provincialism, which relies on some sort of barrier or change to segregate these dinosaur populations. So there have been a number of hypotheses that major river systems or big mountain systems, mountain belts separated these populations in the north from the populations in the south. And so that's something we really wanted to investigate. And as we've continued our work, as you'll see, we've been able to test that and show that this is probably an oversimplified version of what's actually going on Laramidia. So all of our discoveries combined now are starting to show what is probably should be more expected, and that's that life is much more complex than a simple, easy explanation of a couple of mountains separating populations. So some of our new discoveries since I've been here at the Denver Museum include a couple of new duckbills. This is a duckbill dinosaur site that we found my very first season out there in 2011, so 10 years ago. You can see a couple of limb bones there in the foreground with our volunteers digging them up way out in the middle of the Badlands in the Caperowitz. We got them all back, we got them prepared. Unfortunately, it was, fortunately, it was amazing specimens, really a nice skeleton, but unfortunately, most of the skull fits in this little box over here on the right. So all these little fragments are the skull parts. Luckily, there's enough skull parts that we can be pretty certain now that it's this missing crested type of duckbill. So remember, there were 3 in the north and 2 in the south. Now we can say there's 3 in the south. And so we're able to add in that missing crested form. It's a little bit smaller, it's a little bit different. This one seems to be an exception to that, to what I said before, that they're the same genera of different species. This looks like a completely different genus, or at least distinct enough from the northern form. And what that shows us is that these were much more cosmopolitan. So we used to think that that crested form of duckbill dinosaur only lived in the north. By adding in the Caperowitz now, we know that at least at this 76 million year time slice, they were represented across Laramidia. We don't know how far south they went because we don't have rocks of that age. So that's one of the things that we're always dealing with any fossil mystery is missing time or missing information. But we can be pretty sure that they were distributed from north to south and that there wasn't a major difference, at least in this type of duckbill dinosaur. This is the first time I'm showing anybody this. This is a discovery that we made years ago, but we just prepped and just identified this fossil on Friday, so it's been less than a week. This is a site that I found in 2008, didn't get back to collect until 2016, and it's a jacket that's been sitting on our back shelf for the last 5 years. And we finally opened it up a couple of weeks ago. And as we prepped into it, we noticed that it was completely different. So you notice this is the top of the head. The eye would have been down here where this big crumple of toilet paper is. And then this weird flat bone sticking off is actually a crest. And this is a dinosaur from a group that we know as Brachylophosaurans. So it's another type of duck-billed dinosaur. And Brachylophosaurs are all known from Laramidia from older rocks. They're known from rocks that are about 77 and a half and older million years ago. The Caperowitz form, so this new one is about 2 million years younger than the youngest previously known version of this dinosaur. And so we can now say that there are at least 4 different duck-billed dinosaurs in the South. So just over the last couple of years, we've completely flipped what we thought before, that duckbills were more abundant in the North than in the South. We now have more diversity, a greater richness in the South than in the North, including some of these forms that are probably holdovers from some of the older rocks. So this is a kind of a relict population potentially in the South. So it's much more complex, as I said. We have new ankylosaurs, and the ankylosaurs, not surprisingly, tell a different story. One of them that was described a couple of years ago, it's called Echinocephalus. And what's really great about Echinocephalus for us is it reinforced that provincialism. So we have a group of red stars at the bottom. Those are all more closely related to each other than they are to the yellow stars at the top. But since then, we've added a few new armored dinosaurs, and those are completely different. In fact, we have a very close cousin to those yellow starred forms that we're publishing right now. So paleontologists from the BLM and the Natural History Museum of Utah have another type of horned dinosaur that completely scrambles this very simplified provincialism idea. This small little dinosaur, so we're getting out of that big 4, we're going to look at this little dinosaur. It's called an orodrome. It's a little 2-legged plant eater. You see it there with water dripping out of its mouth and kind of a pink furry feather. This is a type of dinosaur that's been known from northern localities for a very long time. This is one of the specimens that we found in a bone bed a couple of years ago, beautifully preserved. This is a juvenile. What you're seeing here is the complete leg. So that's the femur, that's the tibia or shin bone, the ankle bone, the foot, and the foot's wrapped up and under. And then you see here is the upper arm bone. The forearm is wrapped under, so there's the ulna, so the forearm. These are all ribs with the skull curled up on top of it. And if you look at the scale bar at the bottom, this is only 15 centimeters. This is about the size of a kitten. So this would sit in the palm of your hand. This is a little teeny tiny baby dinosaur. So small that if you zoom in on this, you can see these little tiny teeth that are about 1 millimeter wide. So really tiny little dino, but amazing preservation. We also have adults of this form. And what's really interesting is, as you'll see, this fills in a gap and makes things look a little more complex. But all the northern forms up to this point were thought to be burrowers. So they have very unique morphology of their forearms and their pectoral girdle, their shoulder blade, that shows that they were probably burrowing. In fact, several of the different types of orodromine dinosaur from the north have been found in burrows. So they might be digging their own little chambers in the sides of hills or floodplains. In the South, we don't see any of those adaptations for burrowing. So again, this is reflective of the difference in the environment. And that's something we're going to come back to. So very different types of environments these animals are living in. And for a long time, as I mentioned, we thought they were just in the North. It turns out that there's probably an extinction of this group at about 75.5 or 75 million years ago. And the reason we had never found them in any of these other southern bars is because none of these bars were old enough to get into the range of this dinosaur. And so this was an apparent regional pattern that was just due to an extinction event. And so we just don't have them in places like New Mexico or Texas because the rocks aren't old enough to preserve them. There's an extinction event and we just don't get them anywhere else. And so this has led to that false impression again of regionalism or endemism. But let's come back to the horned dinosaurs because this gets a little bit interesting. So again, we've got these 3 amazing taxa. There were more in the South than in the North. So it was a bit surprising a couple of years ago when we started to find some new horned dinosaurs. And so what's really great about the horned dinosaurs from the South to this point is they show us a progression, what we call anagenesis in some form. So a slow change in time from species to species. And that marches from about 79 million years ago to about 72. So a 7 million year window where we see change through time. But we have a crazy amount of diversity. And in 2014, we just discovered this skull in the Leucoperawits in the exact same horizon where we have the other 3 types of dinosaurs. And as you can see, it's quite different. So it doesn't have those weird horn bangs folding forward. It's got a really long horn over the eye. And has a very short face. So it's this weird mosaic of different forms. And what we're really blessed with in southern Utah is an abundance of fossils. And so usually when you find a new species of dinosaur, You're really lucky to get something this complete. This is a nearly complete skull. But we've actually found 7 partial skulls and skeletons of this new dinosaur, and that includes a full age range. So the one in the upper left is a very young juvenile that has poorly developed or still developing orbit horn, eye horn, all the way up to big full-grown adults. So we can be pretty sure that the differences that we see in the skull shape and the horn shapes isn't because it's a different age of one of the others. And we're pretty sure now that it's probably not sexually dimorphic. It's not just a male of one of the other forms. We have enough consistency in ages from all of these to show that these features are pretty consistent. And so this completely throws out even more of that idea and shows that we have 4 different dinosaurs, horned dinosaurs from the south versus 2 at any given time slice in the north. Believe it or not, we found another horned dinosaur recently. So this is one we're actively working on right now. We've spent about 3 field seasons digging this site. This has shoulder blade, parts of the face. So this is the jugal or cheekbone. This is the upper arm bone. This is parts of the brain case. We now have 3 individuals of this dinosaur. And comparing the bones that we've cleaned so far to the other 4 horned dinosaurs from the Caparowits, we're pretty sure that it actually belongs to this mystery horned dinosaur. There was a frill found about 15 years ago of something that we called Centrosaur B. It has small little openings in the frill. It's quite different from any of the other horned dinosaurs. So we think we have a 5th horned dinosaur from the Caparowits. And so rather than 4 versus 2, we're now pretty confident we have 5 versus 2 in the south at the exact same point in time. So remember, this is within the era of the dating techniques. So there's something seriously going on from north to south, even though that provincialism idea kind of broke down with some of the other dinos, something is actually going on. We have other new dinosaurs. Like I mentioned, there's this new raptor that was mixed into the blocks from that duckbill site. But we also have things like new alligators. So this alligator form on the left is actually a true crown alligator relative. It's actually closest to caimans, which are now most abundant in South America. And this extends the range of caimans and caiman-like alligators, alligatorids, about 20 million years into Laramidia. So we think that this clade was actually part of the Laramidia ecosystem. It might have actually originated in this ecosystem. We, of course, have tyrannosaurs, the other part of the big 4. This is a tyrannosaur called Teratophonius. We're in the midst of amazing tyrannosaur renaissance in the Caparowits, where all of the different collaborators at the different museums and institutions are all working on multiple sites. I think we now have about a dozen really well-preserved tyrannosaur skulls and skeletons from the formation. So again, amazing diversity and abundance. And surprisingly, the tyrannosaurs are actually showing that regionalism. And so we are getting dinosaurs from the south that are tyrannosaurs that are more closely related to each other than they are to the ones from the north. And so again, there is still that hint of regionalism. So even though I tried to break it down and show you that some of the patterns were false, this does seem to be real. Just a couple of weeks ago, we had this big discovery of one of these sites with the tyrannosaurs that had multiple individuals. And we were able to show that they were probably gregarious. So they actually came together in some sort of social unit, at least part of the year. We don't know if they hunted in packs or if they did anything else other than come together at points in time. But this unit has at least 5 individuals of varying ages, from very small juveniles to very old adults. But what really tells us the story of what's going on is probably the cold-blooded or the ectothermic animals. So this is a big crocodile called Deinosuchus. This is actually found in that site with the tyrannosaurs. So this is a real type of scene you might have seen back in the Caparowit 76 million years ago. And just like with the horned dinosaurs, you see a very real pattern of difference from north to south. So in the south, we have 6 different taxa of alligator relatives, of alligatorids. In the north, there are only 2. And we know from today that alligators and crocodiles have a mean annual temperature gradient limit of about 16 degrees Celsius. And so after you get your mean annual temperature below 16, that's the line where you don't see alligators anymore. And that extends up into about the middle of Arkansas into the central Texas area. And then they fall away where you don't get gators unless someone releases them, of course, out into a lake or something. And then you get places like Venezuela or the Amazon basin where you do get up to 6 different caiman and crocodile and alligator relatives living at the same time. So we think that this is actually representative of a true ecological gradient that we see in the same way today. We get the same thing when we look at small microvertebrates. So these are the lizards. We have lizards and snakes from Utah. So this is a paper from 2013 showing these differences where some of them are widespread. So the green one in the lower left is a type of lizard that's known from Alberta all the way down to Texas. But you do see regional patterns. So the red and the yellow are 2 different types of lizard that are found only north or only in the south. The one in the lower right, snakes. At this point in time, snakes are only known from the south of Laramidia. And so this seems to be a real pattern. So even though it was broken down with some dinosaur groups, lizards show that this can be quite diverse. And to really test it, we get after the leaves. And so I know some of you really love fossil leaves. And fossil leaves are a great tool for unlocking past climate. So looking at mean annual temperatures, mean annual precipitation. So doing things like leaf margin analysis, at least from what we know from this time period, and plotting that along a gradient, we see what looks like a pretty strong correlation between climate. So there's a temperate zone in the north, which extends from the north slope of Alaska down into that northern Montana zone. And then you get into a seasonally tropical or subtropical zone that includes the Kaparowits in Utah. And so what we think is happening is the same as what we see today, where you have a latitudinal gradient driving very large differences in ecology from north to south. And that's being reflected in some groups, so horned dinosaurs and even tyrannosaurs, but not so much in others. So some of the other dinosaur groups aren't as controlled by these big latitudinal gradients. And this is a really powerful exploration of latitudinal gradients in a dinosaur ecosystem, something we've never been able to do. And so just to kind of sum up what we've been able to do in the Kaparowits, as I mentioned, we've got 9 named species, new species of dinosaurs in the last decade or so. But with our ongoing work, we have at least another dozen that are currently being described, that are in press or are in our prep labs right now that we're working on. So another dozen dinosaurs just from this single rock unit that are really telling us, each one of these dinosaurs is telling us something new about what's going on Laramidia 76 million years ago. So next I want to shift gears to another formation quickly. This is the next rock unit deeper in time in the same place, so still in southern Utah. It's called the Wahweap. And the Wahweap's been known to produce dinosaurs for a long time, but we've only named 5 different types of dinosaurs so far. So a really nice meat-eating dinosaur called Lithrinax that we talked about in the Making North America video, a couple of duckbills and a couple of horned dinosaurs. Diabloceratops is this amazing single skull that was found about 15 years ago. Haven't found one since, but we're still working in the Wahweap. And what we're finding is that it's really important to think of a single rock formation as multiple stacked ecosystems. And so our recent work is showing that these different dinosaurs lived at different times. These basal, the bottom of the formation has a completely different biotic zone than the upper formation. And that's really good because we can then do multiple comparisons within the formation across Laramidia. So the very upper part of the Wahweap is the same age as the Old Man Formation in Alberta that has that same duckbill dinosaur Brachylophosaurus that we just discovered last Friday. And so we can make meaningful comparisons back in time. Same for in the south. In fact, in the south, we can make regional comparisons from New Mexico to Utah, so over a short amount of space. And we're finding new dinosaurs. So this is a new Pachycephalosaur, or dome-headed dinosaur that we found a couple of years ago. We're in the process of naming that along with a much smaller type of dome-headed dinosaur right now. We're naming 2 new horned dinosaurs. So these are reconstructions of what those 2 new horned dinosaurs are going to look like. And we're making other discoveries. So new duckbill dinosaurs. This is a articulated tail and body of a duckbill dinosaur. And what's really neat about this site, you can see there what's preserved. So it's just the articulated tail coming up into the hips. So the hips are in here. Those are the limbs crisscrossed. We were really disappointed at first because as we followed this articulated skeleton into the hill, it suddenly stopped. It just fell apart. But that's actually pretty interesting because what we found in place of the rest of the skeleton were big spherical or oblong phosphatic blobs. And what these are actually giant coprolites of that huge crocodile. So this is evidence of scavenging or predation by that giant Deinosuchus that we saw that was attacking the Tyrannosaur in the previous slide. So this is a really neat taphonomic signature. And for a long time, we've found in the fossil record complete hips and tails of duck-billed dinosaurs. And we never knew why we only got complete hips and tails. And it might be because these big alligators, these big 40-foot long Deinosuchus, were going after the soft parts of the animal. They're going after the skull and the belly and pulling these things apart. And the big, tough, well-ossified hips and bony tails aren't things that scavengers like a Deinosuchus wants to pull apart. It's still getting scavenged by things like turtles and smaller crocs, but the reason we might find a lot of tails and hips in the fossil record is because the front halves of duckbills are really delicious for big crocodiles. Mm. And so just like the Caparowits, we're adding new dinos to the Wawit. So of the 5 that had been recognized, we now have another 7 that we're in the process of naming. So that includes the new pachycephalosaurs or dome-headed dinosaurs and horned dinosaurs, but also some new duckbills, including some archaic forms, some really early branching duckbill forms, which I think are going to really tell us about the origins of these patterns of latitudinal gradients. So the last thing I want to focus on before we touch on some other quick discoveries is New Mexico. And so we've been doing work in the Fruitland and Kirtland formations of New Mexico for the past 7 years or so. It's an amazing place. If you've never been down to northwestern New Mexico, you've got to go. It's really close to Chaco Canyon, a national historic monument. Just right outside of it are amazing dinosaur badlands. And so these are some of the big wilderness areas that you can explore. It's really famous for photography, loaded with fossils, tons of fossil forests and other fossils just sitting out on the surface. The same problems we had in the Caparowits, we have to walk everything in and out. Sometimes we get to use helicopters. This is us collecting fossil plants. So we have amazing fossil floras coming out of these areas as well, and amazing dinosaurs. So this is a horned dinosaur skull. This is a really well-preserved pentaceratops. So this is a dinosaur that's been known for about 100 years from this area, but we're finding more and more. So just spending time down there. And again, helicopters have really cracked the code down there. So we're able to get a lot of dinosaur material out of areas that we would have never been able to collect. And there's the last days of that trailer after I overloaded it with too many dinosaur bones. We used that big helicopter there. The helicopter company donated the time to get those out. And we've made some really amazing discoveries just in the last few years. So this was a new skull of a crested Parasaurolophus, so a crested dinosaur, duck-billed dinosaur. The first skull of this species was found in 1921. My wife actually found this skull in a couple years ago, so 100 years ago. So there's 100 years between the discovery of this skull. And this one's so well preserved that it helped us unlock how these skulls form. And there was a big debate among paleontologists who liked crested dinosaurs as to how that crest was created. And it turns out it's very similar to other crested duck-billed dinosaurs. There was a big debate that it was a unique offshoot, an independent evolution of a crest, but it turns out it's just a modification of the same old regular crest. And so there's a reconstruction of what this dinosaur would have looked like. It's a subadult. We know it would have gotten a little bit bigger, but the preservation is absolutely amazing. And this shows us, again, some of those regional patterns. So before the discovery of this new skull, we used to think that the form from New Mexico, from the younger aged Kirtland Formation, was actually most closely related to the northern forms. But this new discovery has allowed us to reevaluate that frill, or that, not the frill, the crest, and show that there's a southern clade, a southern grouping that's separate from the northern grouping. So again, reinforcing that difference from north to south. Mm-hmm. We have tyrannosaurs, beautiful tyrannosaurs. This is one I'm working on right now. So this is something I just finished a couple of days ago. This is an outline skull drawing of the exploded skull. So this was found completely exploded on the surface. Our volunteers and our preparators in our lab pieced every one of these bones back together from literally thousands of little pieces. So every single one of these little broken cracks is a little tiny jigsaw puzzle piece that they reconstructed into these complete bones. And so in the lower right, you see the full reconstruction of this Tyrannosaur dinosaur. And it turns out that that's probably more evidence of diversity in the South, but it falls within that Southern form. So this is another Southern Tyrannosaur. And then this is my wife on another one of her discoveries. She's one of our best fossil finders. She works at the Smithsonian Tropical Research Institute down in Panama, but she comes up and she helps us find amazing dinosaurs all the time. So this is a new raptor dinosaur, dromaeosaur dinosaur that she discovered a year ago. We haven't been able to go back for it yet though. So hopefully later this summer, we can go back and collect this brand new raptor dinosaur. And what's really powerful in New Mexico is we can follow dinosaur ecosystems through time in a single spot. So the San Juan Basin, which is where these rocks were laid down, tracks the retreat of the sea. And so the rocks in the Southwest are about 76 million years old, so about the same age as Utah. But in the Northeast, they're 73. So you can track that same dinosaur ecosystem for 3 million years. So basically see how a single point that's at the same distance from the sea changes through 3 million years of time. And so it's a really powerful way to look at ecosystem change, plants and animals, as they track the retreat of a seaway. So that's work that we're still doing. Hopefully we're able to get out there again, like I said, later this year, and maybe even next year, get out there with a big crew to go after some more of these big fossil plant localities and dinosaur localities. And we're able to do these comparisons as well. And so at least in New Mexico, we're able to compare with other southern units and see how this change, latitudinal gradient might be different within a short amount of space. And then finally, I just want to end with this. This is some of the new work that we're doing in Texas. We're actually finding brand new types of crocodiles and armored dinosaurs. We're describing a new armored dinosaur right now that looks a lot like the one in this scene. And what that allows us to do now is look at major dinosaur change through time. And so by adding in Texas, we can make comparisons with Utah and some of the rocks that other groups are working on in places like New Mexico and Montana and Alberta. And just the rocks that we're working in have produced dinosaurs at each of these white stars. And if you pull these stars all the way to the left, you can see that we're actually tracking dinosaurs from 82 million years ago to 72, some of them at 500,000 year intervals. So we're tracking, at least in southern Laramidia, a major biotic evolution over a 10 million year time span, something you can't do anywhere else on the globe. So this is a really unique place to work if you're interested in dinosaurs and dinosaur ecosystems and their change through time. And so I want to end there. That's a lot of information, I know, and hopefully it's generated some questions for all of you. And at some point, once we're reopened to volunteers, maybe some of you can head down to southern Utah or New Mexico and join us out in the field for some of these digs. So I'll end it there and see if you guys have any questions.
Yeah. So there'll be a lot. Thank you so much, Joe. All right, questions, you guys. I got 3, so I'll wait to ask them. Let others go first.
I guess I'll go. So it might be a little outside of the scope of the research, but I'm wondering if there's any look into pulses of immigration from Eastern Asia. I'm just thinking because we find therizinosaurs on both sides of the Pacific. How close related are those like hadrosaurs to other North American species, or do we have some that are actually more close related to some of the Asiatic hadrosaurs?
Yeah, it's a great question. It's something we're looking at. So just like with the Pleistocene migration events, dinosaurs exploited the land bridge up in the north, the Beringian land bridge. That was probably around 71 million years ago when sea level dropped for a short amount of time. And what's really interesting is it seems that mostly dinosaurs from Laramidia were successfully invading Asia, whereas only a few Asian forms make it into North America at that point. And so usually when you look at biotic interchange, it's the larger landmass that is able to successfully invade the smaller landmass. In the case of Laramidia, it's actually the smaller landmass that's more successfully invading the larger landmass. And we think that might be because of this really unique situation where you have mountains and dinosaur ecosystems that are sandwiched between mountains and fluctuating seas. And so that's actually selecting for not only these latitudinal gradients, but actually selecting for generalists. And so these dinosaurs are more generalized because they have to be able to respond to these quickly shifting ecosystems and climates. And so they're much better able to then invade the larger landmass when they get the chance. And so things like tyrannosaurs and horned dinosaurs pretty quickly invade and take over in Asia at about 71 million years ago.
Great, thank you.
One of my questions is a follow-up to that. Last night, Jim what was his name? Jim Kirkland from Utah. He was the follow-up speaker with the Tate after your lecture last month. And he was talking pretty heavily about the provincial idea and that the ones in the north that they're getting information on are different than the ones from their south. Have you been following what he's been doing as far as the research on the Utah species, and does that match yours, or is there an inconsistency there?
Yeah, it does. It matches really well. So what Jim Kirkland is doing is looking at that middle Cretaceous window. And that's another point in time where there's a big homogenization. So Europe and Asia are mixing with North American faunas. And so we see a lot of European forms showing up in places like Utah where he's working, and vice versa, a lot of Utah forms showing up in places like Spain and Portugal. And so those are the predecessors of the dinosaurs that get trapped on Laramidia. And so those are the early tyrannosauroids, some of the early ceratopsians or ceratopsoids that get trapped in Laramidia and evolve into these classic forms. So the duckbills and the ceratopsians. And then those basically re-radiate back out, as I said, into Asia, but also into the rest of North America after the seaway drains, and you get T-Rex and Triceratops taking over North America. So yeah, what Kirkland was looking at is the predecessor ecosystems to Laramidia, and explains why we get what we get stuck on Laramidia.
So how many years prior to this, when you say the middle, how many millions of years prior to your 83 is that then?
So his youngest dinosaurs are at about 90 million or 92 million.
Okay,
so about 10 million years older.
Then my connecting question to both of those is, in Oregon at the time at 85 million, we're underwater in our Hudspeth Formation. We've found a couple of floating whatever dinosaur parts. Greg Ritalik from U of O has a couple of them, and then we've been out to find a couple more, and our group's going to go out with U of O and do a couple of weeks dig to look for more. So with those specimens that are from around 85, they're probably Idaho, that would probably associate with more of the northern group that you're talking about. Is that just 2 or 3 million years prior to this significantly different, or do you think they're going to be similar?
So what we think the pattern is at that point, and this is just as Laramidia is being separated away from the rest of North America, and there are other great fossils from the West Coast out where you are, so Oregon all the way down to Baja in Mexico, is that they are part of this big cosmopolitan group. So early on, we think that these dinosaurs are probably not latitudinally segregated yet, so they're similar forms from north to south. And it takes another couple million years to start to separate them out along this latitudinal gradient. So you get local evolution of new forms in the north versus the south. But at this point, at 85, we are seeing that they're pretty similar. And so there are places in Montana and down in New Mexico that have pretty much the same dinosaurs.
Did it get redated? Because for some reason in my mind, I thought it was 113. I thought it was like Albion, Aptian, around there.
Which?
Hudspeth.
I thought it was 85.
Okay.
I thought Snowshoe was 135. Maybe it was redated. That's
okay. Yeah.
And there are some duckbill dinosaurs from around the upper 80s from up in the Pacific Northwest and down into Baja and San Diego and that area.
Okay.
Thanks for making that connection for us. Appreciate that. Other questions, folks? You had a lot more at the Tate Museum. I remember listening to about an hour's worth of questions.
So I guess, is it mainly leaf margin that you're using then, or are you also utilizing a clamp for your leaf climate analysis?
So that first climate analysis, that was done by Ian Miller, who's here at the museum.
Yeah.
And he just did leaf margin analysis from a huge chunk of time. So he's currently breaking that down into smaller time slices. So what that represented was most of the late Campanian and early Maastrichtian. So that was a 10 million year window, pretty much smearing all of that information into one. What we really need are time slices. So we need to go back and look at leaf margin analysis and some of the other proxies for climate at specific time points, looking at petiole size and leaf thickness and everything else.
Yeah, I was in a conference call with Ian about a month ago now. So yeah, say hi to him for me.
I will, and I don't know if you've heard, but he just signed on with National Geographic. So he's leaving the Denver Museum, and he's the chief scientist at National Geographic starting in July 1st.
That's great. Yeah, because I visited him. Our lab was doing a cross-country road trek for a conference 2 years ago, and we talked to him there at Denver and reconnected over Zoom at a conference. So yeah, it's great to hear. I didn't realize
Washington D.C. has a strong pull on our paleobotanists.
Yeah.
So D.C. took Kirk, and then 10 years later is now taking Ian.
Ian, yeah.
Harold Hines here. I'm a historian by professional training, but considerable interest in paleontology. But it strikes me that what you're representing is you've arrived at a critical mass in terms of information. So you're really beginning to make based on that, some significant generalizations, where earlier that simply wasn't the case.
Yeah, and we're adding more than just dinosaurs. I think that's the key to some of the work that we're doing, is getting away from just the early days were dinosaur skull hunters, trying to fill museums with cool dinos. And now we're getting into the lizards and the crocodiles and the turtles, a lot of the overlooked parts of the ecosystem.
But I was struck that almost with every new major discovery, your hypothesis is changing significantly.
Yeah, we're at that point where everything can get scrambled by a single dinosaur.
Yeah.
So one find can completely scramble a hypothesis, which is really exciting, but it's also really frustrating.
Means you haven't.
Well, 2 years ago, I had a shoulder replacement.
Thanks, Harold. I don't think that was a question. Another one that my students will be interested in, because they're familiar with you after having watched the video. When did you first find an interest in paleontology or maybe specifically dinosaurs? And then how did that lead to the education, and what was it that got you to where you are?
Yeah, I'm like a lot of you. I've been interested in dinosaurs ever since I was a kid, and I just never grew out of it. And fossils and exploring the past. I'm originally from Iowa, but I came out west to Colorado when I was young, and really got the bug here in the Denver metro area because we live on dinosaurs. And so a lot of those early discoveries I was talking about were happening when I was growing up. I went up to Colorado State University. I majored in geology, biology, and zoology. So I had a triple major.
Oh.
And then I went off to Utah, which is how I got involved in the Caparowitz and started working in the Caparowitz and Wall-Wheat formations while I did my master's at the University of Utah under Scott Sampson, who's now at the California Academy. And then I jumped out east and started to work in Gondwana. So I went to Stony Brook University out in Long Island and studied human anatomy, and worked in Madagascar and East Africa and Antarctica for a long time. And so that gave me really a great global perspective on what's going on and the influence of plate tectonics and global systems on dinosaur evolution. But really it's the ability in the West to look at dinosaur change through time that drew me back to Laramidia and working in Utah and New Mexico.
Thank you for answering that. That's great. Other questions?
No, I do not have such a plan.
Sorry, I have another one. So for the helicopters, is that something you have to write in for NSF, or do you guys just have, people that volunteer helicopters, or how does that all work out?
Yeah, so this has taken years and years to develop some of these relationships. The BLM's been really helpful. At least in Grand Staircase, there's an annual science budget. So the reason that Grand Staircase Escalante National Monument was originally created 25 years ago was to preserve the scientific integrity of this really remote area. It's a huge chunk of almost 2 million acres in southern Utah. And so there was a great science budget. We were able to start using helicopters. We got to know some of the helicopter operators, at least the private companies. And then some of them have been willing to donate time. So we get money through the BLM for some of the work, and we also get money donated, or a helicopter time donated by the companies, which has really helped us. And some years we don't use it. Some years we can't use them. Some years it just doesn't work out. Or some years, like this year, we'll be able to put sites, fossil sites together, so we can put water and plaster out there, but we'll still have to hike out to them. So it depends on the year, but we're really lucky to have these partnerships. And it really has unlocked the dinosaurs in some of these really remote areas.
Good question. Thanks. Anyone else? Questions? David, you were in the meeting last night. Any follow-up questions for Joe that might clear up things we got yesterday?
Yes.
No, I'm still trying to process all the information from yesterday.
It was quite a list of dinosaurs that Jim went over. This was really nice to be able to follow everything you're saying this time around. All right. Anyone else? There's a chance we'll let Joe go. That's probably 9 o'clock your time. Just you're an hour ahead, Joe, or
Yeah.
Usually for
we
me,
really tax Kirk Johnson and the folks from the East Coast when we get them to talk, because it's 3 hours ahead and
Yeah, I bet. Yeah.
approaching 11 o'clock for them.
several times a week.
So Mackenzie doesn't mind. He stays up till 2 in the morning every day anyway. Anyone else?
Never.
We're gonna let Joe go. All righty. Thank you so much, Joe. I really appreciate you joining us for this. It was a fantastic talk. Those members in our group that weren't able to be here, I'm sure will be pleased to watch the video. It looks like a round of applause all the way around from everybody. Thank you so much. We really appreciate your time and your knowledge on this. Good luck with all your discoveries over there. And I'm sure, I don't want to presume, but are you open to emails should people have questions down the road?
Yeah, or emails if you're interested in coming out on digs, anything like that. So just let me know. I'd love to meet up with all of you in person someday, once we're out of this pandemic and able to do field work again and stuff like that.
Right. Thank you so much, Joe. Appreciate it. Have a great night.
Yeah, you too. Thank you all.
Oh,
Thank you.